Hi, today we are brought here because of a collision between the truck driver, Ms. Lang, and a car driver, Mr. McKinnery. And Mr. McKinnery claimed that he stopped at the flashing red light before proceeding, while Ms. Lang said that she was braking furiously, but Mr. McKinnery didn't stop. So today our agency hopes to provide a physics perspective of this crash. So we start by calculating the mass of the vehicles, and we use this first equation, and we just divided the acceleration from the force, and then after that we use the second equation. The frictional force equals the normal force times the coefficient of friction, and we calculate the coefficient of friction by dividing the frictional force, or the m times g from the frictional force. And then after that, we use the frictional force as a net force in the right back here in the first equation, so this now equals that, so that we could find the acceleration, and we already calculated the mass, so we just divide the mass from the frictional force, and we got the acceleration of the crash. And then we we used this third equation, which is the final velocity squared equals the initial velocity squared plus 2 times acceleration times the displacement. We did that to find the initial velocity. So the final velocity is 0, since after the collision the vehicles would come to rest. And we calculated the acceleration. We were given the displacement. So we plugged in all the numbers, and for the car we got 11.12 meters per second, and the truck was 10.77 meters per second. So Ms. Lang claimed to be having 6.7 meters per second at the moment of impact. So we use this fourth equation, which is the conservation of momentum. And since there's an x and y axis in this diagram here, and the two vehicles were going perpendicular, so we're trying to find the initial velocity of the truck before the collision. Since the velocities were in vectors after the collision, we could use sine and cosine of the given degrees at which they disperse. So since the truck is going along the x-axis, we can just use it, and so we just use the horizontal velocity of the truck, the final velocity of the truck and the car. And then since the car initially is just traveling along the y-axis, it has no horizontal velocity, so we can just take that out. So we calculated initial velocity of the truck to be negative 12.508 meters per second, which is twice as fast as she claimed. And now to Mr. McKinnery, he claimed to make a full stop at the flashing red light. So we're going to be using this third equation again, and we were given the acceleration from the Honda company, which was 3 meters per second squared, and we were also given the distance from the stoplight by the police officers, which was 13 meters. So we come back to this third equation, and if Mr. McKinnery actually did stop, his initial velocity would be 0, and we were also given the distance and acceleration. So when we find his final velocity for the collision, it would have been 8.83 meters per second. But now to find his actual velocity through the conservation of momentum, we do the same thing as we did for the truck, but this time we're going to do it in respect to the y-axis. So since the truck's going completely horizontal, it has no vertical velocity, and we use the opposite sine or cosine function for the final velocity of the car and the truck. So what we calculated, velocity of the car right before the collision was 12.78 meters per second. The max velocity was 8.83 meters per second. So there's no way Mr. McKinnery could have stopped. So therefore, our agency points the blame towards him. He has a legal obligation to stop, and he clearly did not through our physics equations. And Ms. Lang, even though her velocity was almost twice as much as she said it would be, her momentum was so much due to the mass of the truck that there's no way she could have got stopped in time before Mr. McKinnery pulled up. So if Mr. McKinnery did stop, this collision occurred. So therefore, our agency wants to prosecute Mr. McKinnery despite Ms. Lang's mistake.